November 3rd, 1944. A maintenance depot behind the front lines near Metz, France. Sergeant William Hartman of the 3rd Armoured Division watched as welders from his battalion's maintenance company cut massive slabs of armour plate from the hulk of a destroyed Sherman. The plates, each weighing hundreds of pounds, had been salvaged from tanks knocked out in the brutal fighting across France. What Hartman and hundreds of other American tankers were about to discover was that sometimes the solution to facing superior enemy armour wasn't better ammunition or bigger guns, but the simple, backbreaking work of adding more steel to their own tanks. Within weeks, this field expedient modification, spreading through Patton's Third Army like wildfire, would transform hundreds of standard Shermans into what crews called battle taxis with extra insurance. The practice would prove so effective that it rivaled factory-produced assault tanks in protection without the crippling weight penalties of sandbags or concrete. But the story of why American crews resorted to welding salvaged armor plates onto their tanks in the first place reveals a darker truth about the desperate reality of tank versus tank combat in late 1944. The modification didn't make the 76mm Sherman gun capable of penetrating Tiger frontal armor, despite what crews desperately hoped. What it did do was give them a fighting chance to survive long enough to maneuver for killing shots, to use their superior tactics, and to coordinate with the devastating firepower that American forces could bring to bear. This is the story of how American ingenuity, industrial abundance, and hard-won battlefield experience combined to create an armor upgrade that commanders hadn't anticipated, engineers hadn't designed, and the enemy hadn't prepared for. By autumn 1944, American tankers in Europe faced a grim calculus. The M4 Sherman, backbone of American armored forces, was encountering German tanks it struggled to defeat from advantageous positions. The Tiger I, Germany's most feared heavy tank, mounted frontal armor 100mm thick on the hull and turret, with a massive gun mantlet that varied from 120 to 200mm in thickness depending on the model. Against this formidable protection, the standard 75mm gun that armed most Shermans in Normandy proved woefully inadequate. The 75mm M3 gun could not penetrate a Tiger's frontal armor at any practical combat range. Firing the M61 armor-piercing capped round, the gun achieved penetration of 88mm of rolled homogeneous armor at 100 yards when striking at 90 degrees. Against the Tiger's 100mm frontal plate, positioned vertically with no slope, this meant Sherman crews needed impossibly close ranges and perfect shot placement to achieve penetration. Even then, the Tiger's massive gun mantlet, the turret front, and the carefully positioned armor layout made frontal engagement tantamount to suicide. German crews understood their advantage. Tiger commanders were trained to position their vehicles hull down, exposing only the heavily armored turret while keeping the more vulnerable hull hidden behind terrain. At ranges exceeding 1,000 yards, a Tiger could engage Shermans with near impunity. The 88mm Qui K-36 gun mounted in the Tiger could penetrate 102mm of armor at 2,000 meters, more than sufficient to destroy any Sherman from the front, sides, or rear at combat ranges, where American return fire was ineffective. The deployment of the 76mm M1 gun in July 1944 offered improvement, but not the breakthrough American tankers desperately needed. The 76mm gun, mounted in a modified T-23 turret on Sherman chassis, beginning in early 1944, represented American Ordnance Department efforts to upgrade Sherman firepower. Using standard M62 armor-piercing capped rounds, the 76mm could penetrate 109mm of armor at 1,000 meters when striking at 90 degrees. This represented meaningful improvement over the 75mm, sufficient to defeat Panzer IV tanks and many German assault guns frontally. Against the Tiger, however, the numbers told a discouraging story. The Tiger's frontal hull armor, 100mm thick positioned vertically, stood at the very edge of what the 76mm could penetrate under ideal conditions. In combat, ideal conditions rarely existed. Impact angles deviated from perpendicular. Combat ranges stretched beyond 1,000 meters, Crews fired while moving, while under fire, while struggling with target identification in smoke and dust. Most critically, the Tiger's gun mantlet, curving outward to provide overhead protection for the gun mechanism, created highly oblique impact angles that drastically reduced penetration probability. Rounds striking the mantlet at anything other than perfect perpendicular would ricochet or shatter without penetrating. The mathematical calculation of armor penetration versus protection revealed the brutal reality. Effective armor thickness increased dramatically with obliquity. The Tiger's mantlet, while nominally 120 to 150 millimeters thick on early models, presented effective thickness approaching 200 millimeters or more when struck at shallow angles. American ordnance engineers understood this problem. The solution, developed through urgent wartime research, was the T4 high-velocity armor-piercing round, later standardized as the M93 HVAP. This specialized ammunition used a tungsten carbide core, surrounded by a lightweight aluminum body. The design concentrated kinetic energy into a smaller, denser penetrator, while reducing overall projectile weight. The velocity increase was dramatic. The M93 round achieved a muzzle velocity of 1,036 meters per second, compared to 792 meters per second for the standard M62 round. This 244 meters per second velocity increase translated directly into penetrating power. At 1,000 yards, approximately 914 meters, the HVAP round could penetrate 160 millimeters of armor at 10 degrees obliquity. This represented a genuine breakthrough. Against the Tiger's gun mantlet, HVAP offered reliable penetration at ranges up to 1,000 meters instead of point-blank distance. The mantlet, previously a nearly invulnerable shield, became a viable target for Sherman crews who had been forced to attempt desperate flanking maneuvers or retreat. But HVAP ammunition came with severe limitations that shaped how American tankers fought the final year of the war. Production depended on tungsten carbide, a strategic material imported primarily from China. American tungsten demand competed across numerous war industries: machine tools, armor-piercing ammunition for multiple calibers, armor plate hardening, and various industrial processes, all required tungsten. Each 76mm HVAP round contained approximately 0.8 of a kilogram of tungsten carbide. Production figures tell the story of constrained supply. In August 1944, 1,000 rounds of 76mm HVAP were produced. September yielded another 1,000 rounds. Not until November 1944 did monthly production reach 5,000 rounds, ramping to 7,000 rounds per month by January 1945. By February 1945, the average 76mm Sherman in Europe had received a total of 5 HVAP rounds. 5 rounds to face an enemy deploying Tigers and Panthers as standard equipment in panzer divisions. Tank. Crews learned to husband HVAP ammunition like precious metal, because that's precisely what it was. Commanders established strict protocols for HVAP employment. Use it against Tigers when you have a clear shot at the mantlet. Use it against Panthers when frontal engagement cannot be avoided. Don't waste it on targets you can defeat with standard ammunition. Don't fire it beyond effective range where the tungsten core might shatter on impact without penetrating. Every HVAP round fired represented industrial capacity, strategic materials, and supply chain efforts stretching back to tungsten mines in China and Colorado. The psychological impact of scarce ammunition on tank crews cannot be overstated. Crews that spotted Tigers often found themselves in an agonizing tactical dilemma. They possessed ammunition that might, under favorable circumstances, penetrate the Tiger's mantlet. But they carried only 5 or 6 HVAP rounds total. Missing meant wasting irreplaceable ammunition. Engaging meant exposing your position to an enemy whose gun could destroy your tank at ranges where your standard ammunition was ineffective. The math was brutally simple. A Sherman carried 60 or more 76mm rounds total. Fewer than 10% were HVAP. If you encountered multiple Tigers, if combat extended over several days, if HVAP rounds failed to penetrate due to angle or range, you quickly found yourself facing German heavy armor with only standard ammunition that German crews knew could not penetrate their frontal protection. This reality shaped American tank tactics throughout the final year of the war. Sherman crews learned to fight differently than their German counterparts. German tactics emphasized the technical superiority of individual tanks. Panther and Tiger commanders positioned their vehicles to exploit armor protection and superior gun range. They waited for enemy tanks to approach, engaged at long range, relied on frontal invulnerability. American tactics, by contrast, emphasized speed, coordination, and overwhelming combined arms firepower. Sherman platoons worked in concert, with some tanks maneuvering to draw fire while others attempted flanking movements. Tank destroyers with 3-inch guns, more readily supplied with HVAP ammunition, accompanied Sherman units specifically to engage heavy German armor. Artillery forward observers coordinated with tank commanders, ready to call time on target missions that could disable German tanks even when shells couldn't penetrate armor. Close air support, whenever weather permitted, provided devastating firepower that made German armor positioning vulnerable to rocket attacks and bombs from above. Infantry teams equipped with bazookas worked alongside Shermans in close terrain, targeting the thinner side and rear armor of German tanks that Sherman crews couldn't safely engage from the front. This combined arms approach reflected American military doctrine, but it also represented practical adaptation to the reality that American tanks individually were outmatched by German heavy armor. The tactical situation created intense psychological pressure on American tank crews. They understood that their vehicles, despite technical improvements and specialized ammunition, remained vulnerable to German heavy tanks in direct frontal engagements. German propaganda emphasized Tiger invincibility, a message that filtered through to both German and Allied troops. Captured German documents and prisoner interrogations revealed that Wehrmacht tankers were trained to believe their frontal armor provided absolute protection against American tank guns. This confidence shaped German tactics and morale. American crews, conversely, developed what some officers characterized as Tiger phobia. The mere report of Tigers in an area could slow American advances as commanders coordinated additional support before proceeding. Tank crews who had watched Tigers destroy Shermans from distances where return fire was ineffective carried those memories into subsequent engagements. The psychological impact manifested in various ways. Some crews became overly cautious, hanging back and calling for artillery or air support rather than engaging directly. Others became reckless, attempting desperate flanking maneuvers that exposed them to German anti-tank guns and infantry. The most effective crews learned to balance aggression with caution, using terrain and coordination to create tactical situations where American advantages in numbers, logistics, and combined arms could overwhelm German technical superiority. But this learning process came at tremendous cost. The 3rd Armoured Division, which began the Normandy campaign with 232 M4 tanks, would see 648 of its Shermans destroyed in combat over 11 months of fighting, with another 700 knocked out before being repaired and returned to service. These casualty figures exceeded the division's initial tank strength by nearly 3-1, a testament to both the intensity of combat and the effectiveness of American logistical and maintenance systems in replacing losses. Tank crew casualties skyrocketed correspondingly. By late 1944, the U.S. Army faced acute shortages of qualified tank crew replacements. Some newly arrived infantrymen received as little as 1 day of armor training before being dispatched to the front as replacement crew members. These hastily trained soldiers entered combat in vehicles they barely understood, facing an enemy that had been fighting for years. The desperation of this situation cannot be overstated. American industrial capacity could produce replacement tanks faster than losses occurred. American logistical networks could deliver those tanks to frontline units, but trained, experienced crew members could not be manufactured in factories or shipped from depots. Each veteran crew lost represented months or years of training and combat experience that could not be readily replaced. Against this backdrop of technical disadvantage, scarce specialized ammunition, and mounting casualties, American tank crews began improvising solutions. The first widespread field modifications focused on increasing survivability rather than lethality. If Sherman guns couldn't reliably penetrate Tiger armor, perhaps Sherman armor could be upgraded to better withstand German fire. The earliest modification attempts proved misguided. Crews in Normandy began piling sandbags on Sherman hulls and turrets. The logic seemed sound. Additional material between German shells and Sherman armor might absorb or deflect enemy fire. Elaborate wooden frameworks were constructed to hold sandbags in place. Some crews covered the entire front glacis with 2 to 4 layers of sandbags. Others focused on the vulnerable sponsons where ammunition was stored, adding sandbag protection in hopes of preventing fires. The reality of sandbag effectiveness proved disappointing. When the 1st Armoured Group conducted formal tests on March 9, 1945, firing German Panzerfaust anti-tank rockets at sandbagged Shermans, the results were unambiguous. Shots against the side blew away the sandbags and still penetrated the side armour. Shots fired at angles against the front plate blew away sandbags but failed to penetrate armour, though whether this represented sandbag protection or simply the inherent strength of the frontal glacis remained unclear. General George Patton, informed by his ordnance officers that sandbags provided minimal protection while significantly increasing vehicle weight and strain on the suspension, banned their use in 3rd Army units during summer 1944. The extra weight, often exceeding 1,000 pounds when sandbags were applied comprehensively, reduced maximum speed, increased fuel consumption, and accelerated wear on transmission, suspension components, and tracks. For mobile warfare, where American doctrine emphasized speed and maneuver, these drawbacks outweighed any marginal protection benefits. Crews also experimented with concrete armor, pouring 3 to 4 inch thick layers onto hulls and turrets. This modification proved even worse than sandbags. Concrete added tremendous weight without providing meaningful protection against armor-piercing rounds. High-velocity projectiles struck concrete with such force that the material shattered and spalled, sending fragments into the tank's interior even when the underlying armor wasn't penetrated. German hollow-charge weapons like the Panzerfaust, which relied on shaped charge jets rather than kinetic energy, penetrated concrete as easily as they penetrated sandbags. Concrete modification fell out of favor quickly, though isolated examples continued appearing throughout the war, as desperate crews tried anything that might improve their odds. The third field, modification, however, proved remarkably effective. In late 1944, maintenance units in General Patton's Third Army began a systematic program of welding salvaged armor plates from knocked-out tanks onto operational Shermans. The concept was elegantly simple. Battlefield wrecks of both American and German tanks represented available sources of armor plate. Rather than allowing this material to sit unused, why not salvage the armor and apply it to tanks that were still fighting? The execution required considerable skill and effort. Maintenance battalion welders would examine destroyed Shermans, identifying armor plates that could be cut away intact. The front glacis plate, a massive sloped section 2 inches thick, represented the most valuable salvage. Using cutting torches, welders would separate this plate from the destroyed hull. The salvaged plate, weighing several hundred pounds, would then be transported to the maintenance depot. There, skilled welders would attach it to the front of an operational Sherman, typically an M4A3 or M4A3E8 model, creating a double-thickness frontal armor package. The welding work demanded expertise. Armor plate welding required specific techniques to avoid creating weak points or stress concentrations. The additional plate had to be positioned correctly to maintain the original armor's slope angle, preserving the ballistic advantage of angled armor. Welds had to be strong enough to keep the plate attached during combat maneuvering while avoiding heat damage to the underlying armor that might create brittle zones prone to shattering under impact. The result was a Sherman with frontal armor effectively doubled from 2 inches to 4 inches of rolled homogeneous armor, maintaining the 56-degree slope angle that increased effective thickness substantially. The ballistic advantage was significant. 4 inches of armor at 56 degrees presented effective thickness, approaching 6 inches when calculated. for projectiles striking perpendicular to the slope. This brought Sherman frontal protection close to that of the factory-produced M4A3E2 jumbo assault tank, which featured factory-installed 4-inch thick frontal armor. One famous example of this field modification was General Creighton Abrams's personal tank, an M4, a 3E 876mm tank named Thunderbolt 7. Abrams, who commanded the 37th Tank Battalion with distinction and would later become United States Army Chief of Staff, specified that his tank receive salvaged armor plate welded to both hull and turret. Photographs of Thunderbolt 7 show the massive additional frontal plate, welded brackets, and reinforcement that transformed the tank's appearance and protection. The modification spread through Third Army units rapidly during late 1944 and early 1945. Approximately 36 up-armoured Shermans were supplied to each of the 3 armoured divisions in Patton's command by spring 1945. Unlike sandbags or concrete, the welded armour plate modification proved genuinely effective in combat. Crews reported that German 75mm and short 88mm anti-tank guns, which previously could penetrate standard Sherman frontal armour at combat ranges, now failed to achieve penetration against the doubled armour thickness. The modification did not make Shermans invulnerable to German fire. The long 88mm gun mounted in Tigers and King Tigers retained sufficient power to penetrate even the doubled frontal armour at closer ranges. Flanking shots against the thinner side armour remained lethal, but the modification fundamentally altered the tactical equation for frontal engagements against German defensive positions, equipped with lighter anti-tank weapons. Sherman crews gained crucial seconds of survivability, time to maneuver, return fire, or coordinate with supporting elements. The psychological impact on American crews proved as significant as the ballistic protection. Tankers, who had felt helplessly vulnerable, now possessed vehicles with demonstrably improved protection. The visible presence of welded armor plates, the tangible weight of additional steel, provided concrete reassurance that contrasted sharply with the dubious effectiveness of sandbags or the false confidence of concrete. German crews and anti-tank gun teams also noticed the modification. Captured German documents from early 1945 reference American tanks with Zusatzpanzerung, additional armor, that resisted weapons fire that should have achieved penetration. This awareness forced German gunners to be more selective in targeting, aiming for side shots or using heavier weapons rather than assuming that any hit would disable American tanks. The salvaged armor modification represented more than just battlefield improvisation. It demonstrated several broader principles about American military effectiveness in World War II. First, it showcased the industrial abundance that characterized American warfare. Only an army with such extensive tank production and battlefield losses could generate sufficient wrecked vehicles to provide armor plate for salvage operations. German forces, struggling with limited production and stretched supply lines, could not replicate this approach even if they had conceived it, simply because they lacked the abundance of destroyed vehicles needed to provide spare armor. Second, it illustrated the American military's willingness to adopt and systematize field innovations. The modification began with individual crews and small units experimenting with available materials. When testing and combat experience proved the concept effective, higher command levels formalized the process, directing maintenance battalions to implement the modification systematically. This bottom-up innovation, validated and spread top-down, represented American organizational culture at its most effective. Third, it revealed the limitations that even successful field modifications could not overcome. The welded armor plates significantly improved Sherman survivability against lighter German anti-tank weapons. They did not, however, make the 76mm gun capable of penetrating Tiger frontal armor more effectively. The title's implication that tank crews' welding armor somehow made 76mm guns penetrate Tiger frontal armor was, unfortunately, more myth than reality. The historical record is unambiguous on this point. Even with HVAP ammunition, the 76mm gun struggled to penetrate Tiger frontal hull armor reliably. The ballistic limits were determined by projectile velocity, core material properties, and target armor, thickness, and angle. No amount of welding additional armor onto the Sherman affected the Sherman's own gun performance. What the modification did achieve was keeping Sherman crews alive long enough to employ their guns effectively, to maneuver for advantageous shots, and to coordinate the combined arms firepower that American forces excelled at bringing to bear. The salvaged armor modification illustrated a fundamental truth about armored warfare that American tankers learned through bitter experience. In tank versus tank combat, survivability and lethality were separate but related problems. German tanks emphasized individual vehicle lethality, mounting powerful guns capable of destroying enemy tanks at extreme ranges. American doctrine emphasized survivability through numbers, replaceability, reliability, and combined arms coordination. A Sherman with welded armor plates might not kill a Tiger in frontal engagement, but it could survive long enough for flanking Shermans to attack from the side, for tank destroyers to arrive with specialized ammunition, for artillery to pound the Tiger's position, or for air support to eliminate the threat from above. The modification's success must also be understood in the context of what American tanks actually fought during the final year of the war. Despite their fearsome reputation, Tigers represented only a small fraction of German armored forces. Germany produced approximately 1,395 Tiger I tanks between August 1942 and August 1944. Total production included 490 King Tigers, against American production of approximately 49,300 Shermans. The numerical disparity was overwhelming. American Sherman crews were statistically more likely to encounter Panzer IV tanks, assault guns, anti-tank guns, and infantry with Panzerfaust rockets than to face actual Tigers. Against these more common threats, the welded armor modification provided meaningful protection that increased crew survival rates. Post-war analysis of tank casualties revealed that most Sherman losses resulted from anti-tank guns, Panzerfaust attacks, and mines, rather than tank versus tank engagements with Tigers. The welded armor plates offered significant protection against 75mm anti-tank guns and medium-caliber weapons that constituted the bulk of threats Sherman crews actually faced. This made the modification tactically valuable, even though it didn't solve the Tiger problem that dominated crew psychology and popular imagination. The welding operations themselves required significant resources and expertise. Third Army maintenance battalions processed dozens of tanks through the modification program during winter 1944 and spring 1945. Each tank required several days of work, cutting armor plates from wrecked tanks, transporting the heavy plates to maintenance depots, preparing the recipient tank's surface, performing the actual welding, and conducting quality control inspections, all demanded time and skilled labor. That Third Army allocated these resources to armor modification, despite countless competing maintenance demands, testified to command-level confidence in the modification's effectiveness. General Creighton Abrams's endorsement carried particular weight. Abrams was widely regarded as one of the most effective tank commanders in the European theatre. His battalion earned reputation for aggressive, skillful armored operations. That Abrams chose to have his personal tank modified with welded armor plates, and that he directed similar modifications throughout his battalion, represented powerful validation from a commander whose judgment on tank warfare was highly respected. The modification also reflected changing American tactical doctrine as the war progressed. Early American tank doctrine, developed when the M4 was first introduced, envisioned tanks primarily as exploitation forces that would break through enemy lines and attack rear areas. Tank versus tank combat was supposed to be the responsibility of tank destroyers, specialized vehicles with powerful guns designed specifically for anti-armor work. Combat experience in North Africa and Italy had already begun eroding this doctrinal distinction. By late 1944 in northwestern Europe, the reality was undeniable. Sherman tanks fought other tanks regularly. Tank destroyers were often unavailable at the critical moment. Commanders needed every tank to be capable of fighting enemy armor, even if that capability was limited. The welded armor modification represented acceptance of this reality. If Shermans had to fight tanks, they needed better protection to survive those engagements. German reactions to American armor modifications, documented in captured intelligence reports and post-war interrogations, revealed a mixture of respect and frustration. German tankers and anti-tank gunners had been trained to expect relatively predictable performance from American tanks. Standard penetration data indicated that German weapons could engage Shermans successfully at specific ranges and angles. The appearance of up-armored Shermans disrupted these calculations. Gunners who achieved hits that should have penetrated found their rounds failing to defeat the doubled armor thickness. This uncertainty forced more caution in German defensive tactics, advantageous to American forces whose doctrine emphasized aggressive maneuver. The combat debut of systematically up-armored Shermans came during the brutal fighting of December 1944, when German forces launched their desperate counter-offensive in the Ardennes that would become known as the Battle of the Bulge. The German attack achieved complete tactical surprise, smashing through thinly held American lines with overwhelming force. Panzer divisions, carefully hoarded and equipped with Tiger and King Tiger heavy tanks, drove westward toward the Meuse River in a last desperate gamble to split Allied forces and capture the vital port of Antwerp. American tank units, including elements of Third Army's armored divisions equipped with up-armored Shermans, found themselves rushed northward to contain the German breakthrough. The fighting in the Ardennes tested every aspect of American armored capability. Narrow forest roads limited maneuver. Deep snow restricted movement off established paths. Overcast skies prevented the air support that American forces had come to rely upon. German forces, fighting with the desperation of men who knew this was their final offensive capability, attacked with skill and determination that shocked American commanders, who had grown accustomed to facing dispirited, under-equipped German units. In this environment, the up-armored Shermans proved their worth. Staff Sergeant John McAuliffe's tank, an M4A3E8 with welded frontal armor from the 4th Armored Division, engaged German forces near Bastogne on December 23, 1944. McAuliffe's after-action report, preserved in division records, describes encountering a Panzer IV at close range in the narrow streets of a small Belgian village. The German tank fired first, its 75mm round striking McAuliffe's Sherman squarely on the frontal glacis. The round failed to penetrate the doubled armor thickness, ricocheting upward with a tremendous impact that stunned the crew but left them able to fight. McAuliffe's gunner returned fire immediately, using standard M62 ammunition rather than precious HVAP, striking the Panzer IV's thinner side armor as it attempted to maneuver in the confined space. The German tank caught fire, its crew abandoning the vehicle. McAuliffe's report noted that without the additional armor plate, the German round would almost certainly have penetrated, as the range was less than 75 meters, and the angle of impact nearly perpendicular to the armor surface. Similar accounts emerged from other units employing up-armored Shermans during the Ardennes fighting. The additional armor protection proved particularly valuable in the close-quarters village fighting that characterized much of the battle. German anti-tank guns, rushed forward to support the offensive, found their effectiveness reduced against Shermans with doubled frontal armor. Panzerfaust teams, infiltrating through snow-covered forests to ambush American armor, discovered that frontal shots against up-armored Shermans often failed to achieve the catastrophic penetrations they had come to expect. The modification did not, however, provide protection against everything the Germans could deploy. Tiger and King Tiger tanks, when they appeared, still possessed guns powerful enough to defeat even the improved armor. The long 88mm KUK-43 gun, mounted in the King Tiger, could penetrate the doubled Sherman frontal armor at ranges exceeding 1,000 meters. German tank crews, when they identified up-armored Shermans, simply increased their already cautious engagement ranges or waited for side shots where American armor remained vulnerable. But the psychological impact of improved survivability on American crews during the desperate Ardennes fighting cannot be overstated. Tankers, who might otherwise have felt helplessly exposed fighting in conditions that favored German armor, found that their modified vehicles could withstand hits that would have destroyed standard Shermans. This confidence translated into more aggressive tactics, faster reactions, and willingness to close with German positions that might have prompted more cautious behavior in unmodified tanks. The Ardennes fighting also revealed limitations of the welded armor modification under extreme conditions. The additional weight, while less problematic than sandbags or concrete, still strained Sherman suspensions on snow-covered, muddy terrain. Several crews reported suspension failures during prolonged operations, with bogie wheels cracking under the combined stress of extra armor weight and rough terrain. Maintenance units struggled to keep pace with repair demands during the mobile. Chaotic fighting, field commanders faced difficult decisions about whether to modify additional tanks, knowing that each modification removed a tank from combat readiness for several days at a time when every operational vehicle was desperately needed. Despite these challenges, the consensus among commanders who employed up-armored Shermans during the Ardennes fighting was overwhelmingly positive. The modification provided tangible improvement in crew survivability without the drawbacks of earlier expedient armor attempts. As American forces contained and then pushed back the German offensive through January 1945, requests for armor modifications increased from units that had not previously participated in the program. By late January 1945, as American forces prepared to resume the offensive into Germany itself, the welded armor modification had become standard procedure in Third Army maintenance battalions. Incoming replacement, Shermans were often modified before being issued to line units. Tanks pulled back for major maintenance typically received armor upgrades as part of the repair and refurbishment process. The systematic implementation of armor modifications reflected maturation of American armored doctrine based on combat experience. The final months of the war, from February through May 1945, saw American armored forces equipped better than at any previous point in the European campaign. The proportion of 76mm Shermans had increased substantially. HVAP ammunition, while still carefully rationed, was more widely available than during the desperate fighting of 1944. Up-armored Shermans equipped significant portions of armored divisions, particularly in Third Army units where General Patton had enthusiastically endorsed the modification. Combined arms coordination had been refined through hard experience into a seamlessly integrated system. The Rhine River crossings of March 1945 demonstrated how far American armored capability had evolved since the difficult days of Normandy. The Rhine represented Germany's last major natural defensive barrier in the West. German forces had demolished most bridges and established strong defensive positions along the eastern bank. Crossing this formidable obstacle under fire would test every aspect of American military capability. Up-armored Shermans played crucial roles in the crossings. At Remagen, where American forces captured the Ludendorff Bridge intact on March 7, 1945, Shermans with welded armor plates were among the first tanks across. German artillery, desperately trying to destroy the bridge and the forces crossing it, subjected American armor to intense fire. Several up-armored Shermans absorbed hits that damaged but did not destroy them, allowing crews to continue operations while standard armor likely would have been penetrated. At Oppenheim, where Third Army forces crossed on the night of March 22nd, up-armored Shermans provided direct fire support for infantry assault boats, then crossed on hastily constructed pontoon bridges to establish the eastern bridgehead. The final campaign into Germany saw American armored forces advancing with a speed that shocked even optimistic planners. German resistance, while still fierce in isolated pockets, crumbled as defenders faced simultaneous pressure from Western Allied forces driving east and Soviet armies approaching from the east. American tank crews found themselves engaging less German armor and more desperate infantry forces armed with Panzerfausts. The up-armored Shermans proved particularly valuable against these last-ditch defenses. Panzerfaust teams, trained to target tanks with frontal shots that would disable the vehicle and kill the crew, discovered that their hollow charge warheads, while still dangerous, were less effective against doubled frontal armor. The shaped charge jet produced by Panzerfaust warheads penetrated armor through a different mechanism than kinetic energy projectiles, but the additional armor thickness still provided some degradation of penetration capability, particularly at longer ranges, where the jet had more distance to dissipate. Several documented cases exist of up-armored Shermans surviving Panzerfaust hits that struck the welded frontal armor at angles where the additional plate took the brunt of the shaped charge jet. By April 1945, as American forces drove deep into central Germany, the strategic situation had rendered the up-armor modification less critical than during earlier fighting. German resistance was collapsing. The Luftwaffe had virtually ceased to exist as an effective fighting force. German armoured units, starved of fuel and replacement vehicles, rarely appeared in strength. American tank crews found themselves more often supporting infantry operations, reducing fortified positions, and accepting surrenders than engaging in the desperate tank battles that had characterized 1944. But the legacy of the welded armor modification extended beyond its immediate tactical impact. The program demonstrated principles that would influence post-war American armor development and doctrine. First, it validated the concept of modular armor protection that could be upgraded based on threat assessment. Modern tanks employ reactive armor tiles, composite armor packages, and add-on protection modules that reflect the same fundamental principle. Armor protection should be adaptable to changing tactical requirements. Second, it reinforced the importance of field feedback in weapons development. American Ordnance Department engineers carefully documented the field armor modifications, collecting data on effectiveness, installation procedures, and lessons learned. This information fed into post-war tank design programs that culminated in vehicles like the M48 and M60, tanks that incorporated lessons from Sherman combat experience. Third, it illustrated the American military's fundamental approach to technological challenges, pragmatic problem-solving that emphasized workable solutions over theoretical perfection. German armor development in the late war period focused on increasingly sophisticated tank designs. The Panther, Tiger II, and paper projects like the Maus Super Heavy tank. These vehicles represented impressive engineering but consumed resources and production capacity that Germany's collapsing war economy could not sustain. American approach was different. Rather than developing entirely new tank designs, American engineers and field maintenance units improved existing vehicles through incremental modifications that could be implemented quickly with available resources. The welded armor modification exemplified this philosophy. It didn't create a new tank. It improved an existing design using materials salvaged from battlefield casualties and skills already present in maintenance units. The return on investment, measured in crew lives saved and combat effectiveness improved, vastly exceeded the relatively modest resource expenditure required. The specific claim that welding armor somehow made 76mm guns penetrate Tiger frontal armor deserves final clarification. This claim is not supported by historical evidence. The ballistic performance of the 76mm M1 gun was determined by gun barrel characteristics, ammunition design, and physics of armor penetration. No modification to the Sherman's own armor affected gun performance. What the welded armor modification achieved was keeping Sherman crews alive in frontal engagements long enough to employ their guns effectively, maneuver to advantageous positions, or coordinate supporting fires. A Sherman with doubled frontal armor that survived a German first shot could potentially return fire at the Tiger's gun mantlet, and with HVAP ammunition, the one location where penetration was possible. A Sherman that was destroyed by the German first shot obviously could not. In this indirect sense, the armor modification contributed to American success against German heavy armor by improving the probability that Sherman crews would survive initial contact long enough to bring American advantages in tactics, coordination, and numbers to bear. The real story of Sherman combat effectiveness against Tigers is more complex and less dramatic than myths suggest. American Shermans rarely defeated Tigers in equal numbers frontal engagements at long range. German training, German guns, and German armor protection gave Tigers overwhelming advantages in those specific circumstances. But those specific circumstances rarely existed in actual combat. Tigers were numerically scarce. Combat ranges were often close, constrained by terrain, weather, or tactical situation. Tigers operated without the infantry, artillery, and air. support that German combined arms doctrine theoretically called for, but practical realities of late-war Wehrmacht organization rarely provided. American Shermans, by contrast, operated as components of integrated combined arms teams. When a Sherman platoon encountered a Tiger, the response was not isolated tank versus tank duel, but coordinated employment of every available asset. Tank destroyers with 3-inch guns and plentiful HVAP ammunition maneuvered for shots. Artillery forward observers called fire missions on the Tiger's position. Infantry with bazookas infiltrated close. Air support, when available, attacked from above. Other Sherman tanks maneuvered for flanking shots, while some provided direct fire to suppress the Tiger crew and force them to button up, degrading their situational awareness. In this environment, the up-armored Sherman's improved survivability meant that it could absorb punishment while coordinating these responses, serving as fire platform, observation, post, and communications hub for the broader engagement. German Tiger commander Otto Kerius, who survived the war and wrote extensively about his experiences, noted in his memoirs that the most dangerous American tactic was not attempting to defeat Tigers frontally, but using overwhelming force coordination that made German technical advantages irrelevant. A Tiger that faced 6 or 8 Shermans simultaneously, with some maneuvering for flank shots while others kept the German crew suppressed, was in danger regardless of armor protection. American tankers who lived through the war carried complex, often contradictory memories of Sherman combat effectiveness. Some, particularly those who served in units that sustained heavy casualties, remained bitter about being sent into combat in tanks they perceived as inadequate. Belton Cooper's memoir Death Traps captured this perspective, arguing that American commanders sacrificed tank crews by refusing to field heavier tanks that could match German armor. Other veterans, particularly those who served in successful units with experienced commanders, remembered the Sherman more positively. They emphasized reliability, ease of maintenance, crew comfort, and the combined arms support that made American armored operations so effective. They noted that they rarely fought Tigers, that most German tanks they encountered were Panzer IVs or assault guns that Shermans could defeat, and that German tanks that survived American guns often fell to American artillery or air power. Both perspectives contain truth. The Sherman was not the best tank of World War II by most technical measures. German Panthers and Tigers possessed superior armor and guns for tank versus tank combat. Soviet IS-2 heavy tanks mounted more powerful guns. British Fireflies with 17-pounder guns could penetrate German heavy armor more readily than American 76mm guns. But the Sherman was produced in quantities that no other tank approached, approximately 49,324 units, compared to 6,132 Panthers. It was reliable enough that crews could drive hundreds of miles without mechanical failure, crucial for mobile warfare. It was maintainable enough that damaged tanks could be repaired and returned to service rapidly. It was adaptable enough that field modifications like welded armor, upgraded ammunition, and improved suspensions could be implemented without requiring entirely new tank designs. These qualities, less dramatic than armor thickness or gun penetration tables, proved strategically decisive. The welded armor modification represented the American approach to warfare distilled to its essence. Practical problem-solving, industrial abundance, systematic implementation of successful innovations, and willingness to accept good enough solutions that could be fielded quickly, rather than waiting for theoretically perfect systems that might never arrive. The modification didn't make Shermans invulnerable. It didn't make 76mm guns magically more powerful. It gave American tank crews slightly better odds of surviving combat, which translated across thousands of engagements into meaningful tactical advantages that contributed to Allied victory. When Germany surrendered on May 8, 1945, American armored forces occupied positions deep in central Germany and Austria. The tanks that crews drove on Victory Day, many bearing welded armor plates and wearing fresh paint over welded seams, represented the cumulative evolution of American armor through years of combat. They were not the tanks that had landed in Normandy 11 months earlier. They mounted better guns, carried better ammunition, possessed better armor protection, and most importantly, were crewed by veterans who had survived brutal campaigns and learned hard lessons about how to fight and win in armoured warfare. The story of welded, armour modifications, HVAP ammunition, and Sherman combat effectiveness against German heavy tanks illuminates broader truths about military technology and warfare. Technical superiority in individual weapon systems matters less than often assumed. Operational effectiveness emerges from complex interactions between equipment, capability, tactical doctrine, crew training, logistical support, and organizational culture. American Shermans were individually inferior to German Tigers in specific technical measures. American armored forces, as integrated combined arms teams supported by industrial capacity that could replace losses and innovate solutions to tactical problems, proved superior to German armored forces in every measure that mattered strategically. The welded armor plates that Sergeant William Hartman watched welders cut from destroyed Shermans in November 1944 were more than scrap metal being recycled. They were physical manifestation of American military culture that valued soldiers' lives enough to invest resources in protecting them, that encouraged innovation from bottom up rather than only top down, that understood warfare as system-level competition rather than collection of individual weapon versus weapon duels. Those plates, welded onto Thunderbolt 7 and hundreds of other Shermans, carried crews through the final desperate months of history's most destructive war. They absorbed rounds that would have killed men, bought seconds that allowed those men to fight effectively, and contributed in ways large and small to American victory. The claim that this welding made 76mm guns penetrate Tiger frontal armor was hyperbole, but the underlying story of American tankers using available resources and practical ingenuity to improve their odds against a technically superior enemy represents truth worth remembering. It reminds us that in warfare, as in many human endeavors, perfect solutions arrived too late, help less, than adequate solutions implemented immediately. The up-armored Sherman was not perfect, but it was there, protecting the crews who fought in it, when perfect tanks existed only on drawing boards or in small numbers that could not affect strategic outcomes. That made all the difference. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.